As a change of pace from the other robot that I've been building and showing you, I'm taking a little bit of a break, waiting on my solder sucker. As you know, I clipped out some connectors, and I didn't do such a good job of leaving enough clip in there to pull and solder and desolder at the same time. So I'm having to wait on a good solder sucker, which is going to take 4 or 5 days. I still can do some things on it, but as an excursion from that, this is a frame that I bought. It was $110 and from a Chinese company. And everything you see here came in absolute pieces, except ignore the ultrasonics and the control board here. Just ignore those. I added those, and right now they're not doing anything. I did have the control board is working and is controlling the motors, but the ultrasonics is not doing anything. It's not connected to anything. I put it up there as more of a mechanical, just to see if it would fit and to see if the holes were right. The holes that are in it were right, or if I would have to drill some new holes. But this tracked vehicle looks really cool, and it came in a kit form. And when I say kit, I mean kit. Every piece that you see, for instance, on this wheel here, on this wheel, this piece and the pieces that join it with this piece were all separate. They were all in a bag, along with every other piece and wheel that you see. There was nothing was put together. It was a bag of 1,000 parts with no instructions, and the only picture I had to go by was the one that was on the website of it. And I'm not very good mechanically, but I managed to put it together, and it does function somewhat. The track, I had some problems getting the track on and getting it timed right with the gearing motor. The motor. This is the motor side. This is the motor side of it, and getting the teeth of the gear, which there's 2 of them. There's one back here and one here, and then they're coupled to the motor, which I'll show a little bit better close up. And they go into the track, and they're the ones that force the track around. And getting those timing right, where each tooth of the gear is aligned such that it would drive the gear, that was very difficult to get working right. And again, there was no instructions, no diagrams, no exploded diagrams, no nothing. You just have a bag of 1,000 parts, and you're on your own, and 3 Allen wrenches that came with it. Now the motors on it, the left and right motor, are good, strong motors. They will carry it pretty good. They'll carry, this will probably carry a couple of kilograms of weight total, but it has a problem with the suspension. The natural way this thing goes, these are sprung loaded. You have springs back here. Let's see if I can find the springs or get a good picture of the springs. Yeah, here they are. These springs here give it a natural suspension for, as you can see, that one. And those don't work properly, and so any weight above a couple of kilograms will mash those down, and the track will just come right off. In fact, I can just like that, just like I'm doing now. It'll mash it to the ground, and then the track will come flying off, just like that. Although I do like it, I like the idea of it. It goes fast. It would need a fast What I'm thinking of doing is not even putting this on a servo motor, the ultrasonics like I have here, but simply pointing it out in the forward direction, and because it's so fast, and just letting it rip through, you know. And if it runs into something, it runs into something. I might put one of those laser obstacle detectors on it too. I wouldn't buy it. I don't recommend it unless you really like mechanics, you really like to assemble mechanical things, and you don't really want to put a lot of weight up here. You're not looking to put a lot of gear. That's the reason why I built my own. I like putting a lot of gear, a lot of environmental detection. I want to put GPS, I want to put some other things on it. It's going to take some weight. That's why I built my own. This one would not take all that weight. This one's going to take ultrasonics, a battery, and that's why I bought the smaller battery, which is somewhere. Here it is. That's why I bought this smaller battery to go here, because it needs the less weight. The heavier battery, when I put it in, actually causes it to weight down like that, one way or the other. It'll weight it down wherever I put the battery. And you can put the battery underneath. It's got some places here where you can insert the battery, and then I was holding it on with tie straps. But it's still too heavy. Now this smaller battery will be, I think, just right for it. And I do want to get it working. And by the way, I have this hooked up. It's another slight excursion here. I have this hooked up to a monitor, a battery monitor. As you can see, this battery is at 12.38 volts. It's a LiPo battery. And I can go through the modes on this. I just bought this, and it has horrible LCD contrast. But it does serve a purpose. It does let you know what the cells are individually, and it lets you know what the current percentage is, which I believe is down in this corner at about 95%. So I've got there's the total voltage, 12.38, and I just leave that on there to let me know what state that battery's in. I did the same thing with the large battery that's on the large platform that I built, and I've got a similar one on there, only it has an alarm such that when it gets to the point that it needs charging, the alarm will go off, and I won't or overuse it. And then I'll be able to, when the alarm goes off, that's when I'll be able to charge it. And I'll show you that later too. But I wanted to show you this tracked vehicle. And unless you really, really want to build piece by piece each and every individual part, which it took a day. It actually took 2 days to do. Because I would build something wrong and then have to take it all apart and put it back together. I wouldn't get it. If you're very mechanically inclined and you feel like spending a weekend building it, and you don't mind the fact that it's got some quirks in it, it's not that stable, then it's a good project. But other than that, I don't recommend it, especially for $110. There's some other things I think I would have rather spent my money on now that I have purchased it. If we take a closer look at the top of it, we can see the terminal blocks that I purchased that I had mentioned before. These are those same terminal blocks, and there's the red for the hot side, the plus 12, and here's the ground side, and you can see I've got these metal plates that fit in there that will give, now I have access to all of this is 12 volts, all of this is ground, and it gives me easy access to put in power supplies, you know, down converter power supplies to 5 volts or whatever I want to do, but it gives easier access to it. This is the motor control board. This is a newer version of this is the actual Arduino motor control board, and there's some ways I like it a lot better. One is you have access to all of the Arduino pins along with the motor control itself. So if you want to, put additional functionality on, you can by using the Arduino pins that are there. It does have some connectors for other things, but you can use DuPont connectors to place on there. They fit on there quite well, and can use it for other functions. But they put those there meant for sensors or servo motors. And I've got enough servo motor controllers that I don't need to use what comes off of a motor control board. And the ultrasonics. These ultrasonic detectors are kind of nifty. I'll show you how I put those together. Excuse me a moment while I get these. I ordered about 10 of these, and they've got this cutout shape that fits the ultrasonics perfectly, and it's a kind of an L bracket. Let me grab I bought 10 ultrasonic distance measuring sensors, and it's got 4 pins. It's got a trigger, an echo, and a ground, and a VCC. And what I do is put those in there like that, and I just glue that down with some glue, kind of like super glue. It's a little different, but it's kind of like super glue. Glue that down there, and that fits very well. And then I can plug in my wires here, and you have a nice mountable ultrasonic detector. And you could either mount that on a servo motor, or you can mount it solid on something, and it works very well. And these were purchased on eBay. And ultrasonic holder, if you look for ultrasonic holder, you'll find it. Here, of course, if you just look for ultrasonic sensors, they're all over the place. And these were about $1 each. These were about $1 each. So I think 10 and 10. I think I got the set of 10 and 10 for $20. But it ends up working very nicely. This is the base of the robot. This is the big robot that I've shown you, and looks a little bare without its motor control board here, which is what I've got to solder on, desolder the connector so I can get the ultrasonics, or rather the UART working between the ultrasonics board and that. But what I wanted to show you was this monitoring circuit. I don't understand why they have the LEDs there. That's just going to drain the battery, but they do. They have the LEDs there. This is telling me that all is well, that it doesn't need to be charged. And if we see red on this other side, I believe that's when we have to charge, but it has a little buzzer that will go off, and we can test that. Yep, there's the buzzer, and there was the red and the green. That's saying that the 3 cells that are inside there, I guess an LED for each cell, is fine, and and it's not buzzing, so we have plenty of voltage inside the battery. And I'll just leave it on there, and I'm going to leave it on there it's just going to be part of the battery wherever it's at, whatever it's doing, and then when the buzzer goes off, that's when I'll charge it as a means of protection, because I had really no way of knowing whether I needed to charge the battery or not, and I don't want to under or over discharge it because it will ruin it. If you overcharge it, if you undercharge it, they're like hothouse orchids, these lipos are. You really got to be careful with them. But the advantage is you get a lot of power for the weight that you're having to put up with. And this was $2.50, and it's a LiPo battery protector. You can look it up for LiPo battery protector, and you can find it. It's about $2.30 for one. And then the other one that I showed you is about $5. I wanted to buy two different ones just to see what they were like. This one was about $5, and I'm not happy with the contrast on the, as you can see, the 9 on the 93% there is kind of faded out, but you can still read it, and it's it's $5. So I just figured it was a Chinese special, and it was $5, and it will give me the voltage, and it'll tell me if I need to recharge it. Well, that's where I'm at with, that's where I'm at with the other one. I just wanted to show you that other one. We'll go in more detail once I get that running, or once I start working on the tracked vehicle, which I'm going to pan over. Sorry for I'm going to pan over into that mess that you see. And once I start working on that, I will show you on some film what needs to be done with it. I didn't want to film building it because it was just insanely boring to do that. It was interesting putting it together, but I don't think it would be interesting to watch somebody put it together. Just as a challenge to try to figure out how to build that thing based upon a picture on the internet and with no diagrams or paperwork to go along with it. I wrote the seller and asked them for a diagram, and they didn't have one. So I said, you had to have a diagram. You cut this out. It was CNC or milled out or cut with a laser or something. You had to have some sort of diagram, and when you designed it, but they weren't willing to give that up. So anyway, it's got plenty of holes in it for putting various things in. It's got holes made specifically for servo motors, and so it will be helpful in some ways. In other ways, the holes don't match up with what you're going to put on, so you got to drill new ones. And the strength of the motors is not all that great, but it will carry, like I say, it'll carry a couple of kilograms, even though it kind of mashes down the tracks a little bit. But you tighten up the springs, you tighten up the wheels that the springs go to, and you can help that out a little bit. It is in deep contrast to the homemade one, which I actually prefer, not because I made it, not because it's homemade, but because it carries weight. It carries a lot of weight, and it will carry all of the functionality that I want to put on there. Not just the ultrasonics and the rangefinder, but I want to put a GPS, some other sensors that I can't think of at the moment, but I've got some other things that I want to put on there. That I was going to put an arm on there, but I scrapped that idea because what's it really going to get to pick up? what's it really gonna, how's it gonna sense it, and how's it gonna pick it up. And so I scrapped the idea of putting an arm on there. It's just not gonna be that sophisticated. That will be, if I build an arm, that'll be for another project. And that is the update for the motor tracked vehicle, and I'll be right back. You know, we're back. If you're going to build anything with Arduino, you're going to need more than one. You're going to need several. And so what I have here is I have these are just my spares. The other 6 are being used for different things right now. But I have an Arduino, and there's a Mega, and here's another Arduino. And so as you go along and you come up with ideas of doing something like controlling a servo motor, or getting GPS data down, or doing something like that, you're going to want to do it on the lab bench first to make sure it works, and then you know, put it on your robot, or put it in your application, whatever it is, or just have fun with it. And you know, a lot of things I build and then just take apart. Oh, one of the things I want to do is for the robot is to have a people detection. Well, that's easy enough. I'll use a body heat detector, one of these same detectors that get used in the corner. You'll see them up in the corner, and they'll light up. One of these right here. I bought a pack of 10 of these for about $10, and they are very good at detecting people. So I want to just put that out there. When it detects a person, then it would you know, react accordingly, either coming toward the person or away from the person, or just start talking or doing something. And these are a real simple interface. When they detect the person, you get a positive voltage out, and then that can trigger something. That can trigger, send that back to Arduino and interrupt the Arduino to do whatever you want it to do. That requires only a pin on the Arduino. I do have a talking, a device that talks. Now this is perfect use of, or the perfect example of having an Arduino that you want dedicated to a certain purpose. It can do other things, but right now it's dedicated to speech, and I would like to put that on a robot and then trigger it some way. And if I plug it in, you'll hear it talk.
Hello, I am Billy's robot. Please leave me alone. I would like to sing you a song. Daisy, Daisy, give me your answer too. I am half crazy, all for the love of you. It would be a stylish marriage. I can't afford a carriage, but you'd look sweet upon the seat of a bicycle built for two.
And that is so far what it does. The part of that I programmed in the part where it says it's my robot and to leave it alone, and which fits more with my personality. But where the magic is done here is this TTS board, this text-to-speech board here, and it has a simple interface, not too many wires. Go over to the Arduino and a speaker, and then I put a light on there just to have a light. It's not necessary. It's a big jumbo LED. I just wanted a light there. And the Arduino is programmed. There's a library for it, and you download the library, which is pointed at by the Arduino site, the Arduino cc.cc site. It points to the library, and you can basically go in and put in any speech you want and have it talk. And I want to use a case statement where it says different things at different times. When it detects a person using the using the heat detector, using this body heat detector, it would say something. When it runs into a wall, when the laser sees something, it would say something, and it would give it a personality and kind of let you know. It served two purposes. One is it gives it a personality and it's talking, but another is it's communicating to you. It's telling you what it's doing. It's running into a wall, it's trapped, it sees a person and reacts to it, reacts to the person, and a way that the robot can tell you what's going on with it. And so I definitely want to put a speech circuit in on it. Well, I can do that with this platform. I cannot do that with the tracked platform. There's just not enough room, and also the additional weight would, well, any additional weight, it doesn't like very much. So I have plenty of room, and I'll be able to put it on this homemade robot and have speech capability.